Whoop. Good. Okay, we're recording now. Right. If you can write that down. Scalars and vectors. That's what we're going to have a look at now this morning. Easy lesson, I hope. Did you look at any of the words for this? You read this? You learned some new words?
Yeah.
What words do you know now?
Yeah. I write the translate.
You translate some words. Good, okay. So let's have a look at this. Scalars and vectors. So maybe, Ben, you know these words?
Yeah.
What about you, Gao? Do you know these words? Yeah? Let's have a look. So, Ben, what's a scalar? What would you say? Want to check?
Meter.
Yeah, meter's like a scalar. Yeah. What would you how would you describe it? Gao, would you know?
Maybe the length and direction.
Like a length, yeah. But not a direction. You see, what a scalar is a is a quantity that has only a magnitude, but no direction. So, for example, if you walk at 1 step per second is a scalar. However, walking at 1 step per second to my home, that's not a scalar, because this one has a direction. So a scalar is a quantity that has only magnitude and no direction. So if you could write this down, that would be great. I should tell you that this is a common exam question. They ask you what is a scalar, what is a vector. It's a common question. Did you both have breakfast this morning? Oh, are you one of these people that don't eat breakfast? Oh, that's so terrible. What about you, Ben?
2 pieces of work.
Yeah, that's okay. Butter, jam, or just plain?
No.
Nothing on it?
Yeah.
Nothing?
No.
Just 2 pieces of bread? Oh, that's so sad. So sad. Hot or cold? Cold bread with no butter. So sad. So sad. Yeah, I understand. Okay, you got that? Yep. Alright. Now, do any of you know what a vector is then?
This direction.
Yeah, it has a direction. It's nearly the same. It's a quantity that has magnitude and direction. So, for example, if you walk 1 step per second to my home, it's a vector. However, 1 step per second is not a vector because it was a scalar. Again, this is also common. In the exam, they often ask you, what is the difference between a scalar and a vector? So what is the difference between a scalar and a vector? How are they different?
Direction.
Yeah, the direction is what makes them different, isn't it? Yeah. Okay, is that okay? Yeah. So next now, So, some important examples of scalars and vectors. Speed and velocity. So, most people, most native speakers would say speed and velocity mean the same thing. In fact, they're different. So, we'll say what each is, but speed and velocity are not the same in physics. Like, they're nearly the same, but they're not quite the same. You see, speed is the change in the distance per time. So, for example, 50 kilometers per hour. That's a speed. Is that a scalar or a vector? It's a scalar. Yeah? Okay, good. Or 10 meters per second. Or 1 step per second. They're all speeds. And as a formula, the formula for speed is speed equals distance travelled over time taken. That's all fine. So what you would need is, you don't need to write the example, but you should write down this and this. Can you please also write down speed is a scalar? Speed is a scalar. Yeah. That's okay, yeah, you can write it like that as well. Unit time, yeah. Can you also write speed is a scalar? Yeah? Yeah, it's okay. Now,
Speed is scalar.
is a scalar.
Ah.
You can write anywhere. We'll look at velocity next. I'll go to the next slide, it's okay? Yeah. Okay, so velocity is the change of position, which is also called displacement, per time. That's not quite this, it's not quite the same as this. This one is the change in distance, and this one is the change in displacement. For example, 50 kilometers per hour due north, or 10 meters per second to the finish line, or 1 step per second home. Home, that means home. They're all velocities. Okay? And as a formula, velocity is change of displacement over time. Now wait, before you write that down, I just want to explain the difference here between distance and displacement. Or maybe one of you knows the difference. Do either of you know the difference between distance and displacement? How are they different?
The distance
Yeah.
and displacement.
Yeah, how are they different?
Of direction.
There's a direction part to it. Look, let me give you an example actually. Look here, please. Origin. So let's say he starts here
Yeah.
and he walks here. So you say his distance maybe is 10 meters. Okay? He starts here, maybe he walks here, and maybe he goes back 2 meters. His distance he travelled is 12 meters. 10 plus 2. Okay? But his displacement is 8 meters, yeah. So you could have this. He could start here, he could walk 20 meters, 10 and 10, but then his displacement would be 0. Yeah, because he's back at the start then. So velocity is the displacement over time. Yeah. And it's an example of a vector because it has a direction, like due north. you know. So, for example, here, you would say his displacement is 8 meters right. That's his displacement. But, you know, it could be like this. He could travel 10, and then he could travel 12. So what would be his displacement? It'd be, yeah, left 2 meters, 2 meters left. Or also minus 2. So it has a direction. Distance doesn't. Here his distance is just 22. Okay. You know this difference? You've seen it before? That's good. Okay, and it's a vector. So you can write this down. Velocity is a vector. If you can write that as well, that'd be great. Now there's a great way to remember this. Speed is a scalar. Velocity is a vector. I never noticed that before until maybe 2 years ago. Someone noticed it, and I never noticed it. Speed is a scalar and velocity is a vector. So you shouldn't confuse them now. Okay. Right. Displacement is also a vector, and it's the position of an object. For example, the ship is 2 kilometers to the east, or the man is 3 kilometers east of his home. These are displacements or positions. Displacement or positions. Okay, so can you write that definition down? Displacement.
It is the position of
Yeah. So displacement points to where something is. So like, she is 1 meter there, and you are 80 centimeters there. You know, it points to where something is. So for example, like here, you could say he is 10 meters right, and she is 2 meters left. So that's it. The reason I say it's like a position, because it's like in maths. You know, in maths you have x-axis. So maybe he's like at 10, 0, and she's at minus 2, 0. So the displacement is a bit like this, the position. Like a coordinate nearly. Okay. So you should say displacement is a vector, it is the position. Okay. Is that okay? Yeah? The English is okay? Now, terms like homebound and to the finish line, they're directions, but they're not very useful. So we need something more precise. So often vectors you give as a magnitude and an angle, and you can put the two together to make an arrow. So this is normally how we draw a vector. We say, you know, he's here, and we can draw an arrow to represent it. The length of the arrow is the magnitude, and the direction is the angle here. And this is the tail, and this is the head. The length represents magnitude, and where it's pointing represents the direction. So for example, you know, if I do something like this, I could say he is 10 meters and that's 45 degrees. Or I could say something like maybe she's here. That one could be like, maybe that could be 2 meters and that could be 30 degrees. So you can represent the vectors using arrows. The important thing is that this one, if this is 10 and this is 2, then this should be 5 times bigger than, now I know in my picture it's not, but it should be 5 times bigger than the other one. It should be to scale, you know. So like if this is 1 meter, then this means this is 2 meters and that's 3 meters. Yeah. And this, they're different. They're not the same vector. Because one points northeast and this one points southwest. They're different vectors. Even though maybe they're both 10 meters and this is also 45. Okay. So you need the vocabulary: magnitude, direction, tail and head. That's all the parts of the vector arrow. So can you draw this? Okay, you do that? Right. Okay. Let's do these together. I want to draw all of these. So let me just make a nice big clear picture here. Okay. And you should draw these too. Alright, so the first one. 5 meters per second north. Okay, so just in case you don't know, well, maybe you do know, which one is this?
No.
This is north. This one?
Yes.
This one?
Sounds
Good. And
west.
okay. 5 meters per second north. So that could be like, maybe like that. So that is A, vector A, 5 meters per second north. Okay, 4 meters per second east. So look, if that's 5, 1, 2, 3, 4, 5, then 4 east would be like 1, 2, 3, 4. That would be 4 east. Yeah? Okay so far? 5 meters per second west. Okay, well that's fine. Okay, 1 meter per second south. That's D. Now to the interesting ones. What does this mean? 3 meters per second, 30 north of east. What does that mean? 30 north of east.
So,
Yeah, and where would you put the 30?
north, so
Yeah.
uh,
No, the other one, yeah.
This one.
Yeah. So 3 meters per second, 30 north of east. That's here. This is 30 degrees north of east. It means you start east and go 30 north.
Okay.
Yeah? Okay, so be careful with that, north of east.
Uh,
Yeah. Yeah.
oh,
Is okay? Yeah. Next one. Now, what about this one? 3 meters per second north 30 west. Have you seen that one? So this one here, north 30 west, it means you start north. It means this here is 30. This one is north 30 degrees west. It means start at north and go 30 to the west. Okay, so that one is F. That one was E, wasn't it? Okay, so be careful with that. That's north 30 west. Yeah, okay. Next, 1 meter per second bearing at 30. Now, what does this mean, bearing 30? Does anyone know this one? I probably not. This word means you measure from the north. So it's like this. Okay, that's G. This means bearing 30. So the word bearing means you measure from the north and you go around like that. Yeah. And then the last one is 2 meters per second at 30. So what does that one mean? 2 meters per second at 30. Yeah, from where? From which line? No, actually, from east. Because this one is like in maths class. You know, in maths class you measure from here. So that's what this means. It's just at 30. So like it would be here. At 30. Yeah. In China, in physics or in school, which ones have you seen or used? For example, have you used 30 north of east or north 30 west? Or yeah, but if you translate it, is it more like this or more like this? Or north of east? Not like this. What do you think, Ben?
off.
Okay. Do you use this much in China? In school? Have you used this in school much? Yeah, we do. Yeah. It's the English is a little bit difficult. It's a little bit difficult. Normally in the exam, not always, but most of the time in the exam, it's just like this.
Oh.
Or sometimes it might be. Actually, I should say this one. Sometimes it might be like this, just. You know. Northeast, southwest. Do you know these ones? Northeast is this. But this is exactly 45, yeah. And southwest is this one here. Northeast, southwest, northwest, and what else did I miss? Northeast, northwest, southwest, southeast. Okay. Right. So, that's fine. They're not too difficult, right? How are we going for time? So what I will do, we'll practice these for a few minutes and then start the next lesson. Okay, so I think you could finish them all now and have nothing for homework. I think it should only take you like, I don't know, 5-6 minutes maybe. They're quite short. So the first one is in simple English. What's the difference? Now you have have these done, Ben?
No, looks fine.
Yeah.
Now the 4.
Not 4. Okay.